So as we saw yesterday, that we have this value called the eccentricity, right? And that just basically tells you how elliptical it actually is, right? So an eccentricity of 0, it says down here, right, is a circle. And then as the foci go further and further away from one another, it becomes more elliptical, and therefore the eccentricity increases, right? It can go all the way to 1 and get really, really high, and then if it actually goes bigger than that, we get this other shape we're going to look at tomorrow, the hyperbolas. Okay, that's where the eccentricity is actually higher than 1. Okay, so that's what you're looking at. And you're going to use that to help you calculate and find the equations of the ellipses today. And it's a very straightforward formula. It's C, the length of the focus, divided by A, the length of the major axes. Okay, so just adding that in today, so let's do right here. Do a little bit of this. So, as I just mentioned right here, close to 0 is circular. Circular. And then as you get closer to 1, it becomes more elliptical. Elliptical. I think there's a P in there. Okay, so what do we use this for? So if we're given this information, such as the eccentricity is 3 over 5, right, which is what, 0.6. One thing to note that it does not mean, since it's a C array, it does not necessarily mean that C is equal to 3 and that A is equal to 5, right? This could be a reduced fraction, which it is in this case in this problem. So what you don't want to do is just say, well, I have A and B, or C and A, and I can find B just by using that formula. Okay, don't jump to that conclusion. So on these types of problems, you want to actually just work them out with a graph at hand, right? That's going to be your best approach on these. And then you can figure things out as we go that way. So have a little sketch going on and take the information that they give you and then plot it. So it says the foci are at 5, 1, so you can just estimate this, 5, 1, and negative 7, 1. And then also, before you start anything else and start, solving a bunch of stuff, put down the formula that you're going to use. Okay? So actually get this in there, get this going. That's going to be y. And the first thing we need to determine is, where is the major axis? Where does the a squared go? Below the x or below the y? Alright, so which way is this going to open? Left or right or up and down? Left and right, so horizontally, therefore the a squared has to go underneath the x. So very important detail, otherwise we can do all the right numbers, but then they'll be the bottoms might be switched. So if the foci were like this, up and down, right, then I put the a squared underneath the y variable instead of the x. Right. So I'll keep that there. All right. So this lets us know I need a center point, right, and I need to find a squared and b squared. So it gives you a little checklist to go through so you know when you're finished. So we need to find the center, which is just the middle of the foci coordinates. Or like on the next problem, they give you the vertice, also the middle of those coordinates. So if you're getting some coordinates, chances are the middle of those, or the midpoint of those, is the center. So you can just take these and do the midpoint formula. Right? So we'll have 5 plus negative 7. Find the middle by dividing by 2, taking the average of them. Of course, one of the coordinates will not change, right? Because we're not moving anywhere there. So first step, we're going to find that center point, right? By using the midpoint formula. And we got, what, negative 2 divided by 2, comma 1, which is negative 1, comma 1. We can plot that. Here, negative 1, comma 1, should be approximately in the middle, right? And we can put it in our equation, right? So a negative 1 for the x will be plus 1, and then minus 1 for the y. Right. There we go. So that's going to be step one usually, is to find the center point and plot that. All right. Now, they don't give us information about anything else really except this value of the eccentricity. So that's where we're going to start using that. Let's see here. Yep. All right. So how can we use that? Well, we do know that the distance from here to here, right, is how much? 6. And now what value is that? Is that A, B, or C? Distance from the center to the foci. So you can always check back up and look at what we did on the basic notes here. It should be right there. And yeah, the distance from center to the foci or focal point is C. So we do have C. C is equal to 6. And along with the eccentricity, which is C over A, right, we can solve for what A is. So we'll take E. Let's do that right here. E, which is 3 over 5. Right? And then that's going to be equal to 6 from right here over A. So this just came from here, whereas the 3 over 5 came from what we were given. So we can use that to solve for A. So A comes out to be equal to 10. And that will give us the vertices. Right? That's A, I'll put this in blue. A equal to 10. So now, if I'm 6 away here, if I go 4 more, right, that's going to be one of the vertices. And 10 more this way is going to be one of the vertices. The end of the ellipse. Right? Also, we can now fill in what A squared is right here, right? So I can make that A squared, which is 100. Lastly, we got B squared. We need B squared. How can we find B squared? So we got another formula for that. We got C squared plus B squared equals A squared. Right? So if we have A and we have C, right? C and A, we both have them, so we can find B. So we have C squared, which we know is, let's see, 6 squared, plus B squared, equals A squared, 10 squared. And now it's just a matter of solving, right? We got 100 minus 36. B squared is 64. So now I have B squared, and I can put that up here, 64. And once your equation, all the numbers are filled in, that's how you know you're finished. Now, it doesn't actually say to graph it, but we could go through and graph it and say, well, B is equal to 8, right? And this would be 8 up from the center and 8 down from the center. And then we could actually officially graph this as well. Of course, it's just a sketch. It's not drawn to scale or anything, but at least you have a general idea of what it looks like. So we have, this is 8. And then from the vertice to the center, that was 10. So there's your A, 10, B is 8, and 6 was the C. All right, and we got your equation. Now, these problems will be different from one another. It's not like you're going to use this C squared plus B squared equals A squared in every problem, right? You may or may not need to use all of this or some of it, but just don't try to use this as a template to solve every problem, because you're going to use any trick that you want, any formula that you want to solve these. Some are easier than others. Like on this one, it's actually a little bit easier just because you You can graph it and plot it and just kind of figure out the values that way. So go ahead and give that a shot right now. See how that goes. So you probably figured out by now, we got our center. Last problem was foci, this time it's vertices. Same thing, find the midpoint. And hopefully you caught that this is opening vertically, so the a squared is below the y. Okay? That's very key. So that's different from the last one. You have to check every problem, which way is it opening, and make sure that a squared is in the right place. And then the distance from the vertice to the center, is that A, B, or C? From center to the vertice? That's A. And A is equal to 5. That means A squared is 25. And then minor axis is 8. So all the way across, this is a length of 8. So what's the value of B? Yeah, so B, because of that, B will equal 4. All right, so B squared is 16. Voila. Something like that. Close enough. Good. Alright, so similar looking questions, but how we solve them is quite different. I mean, both started with finding the midpoint, but, you know, over here we had eccentricity, had to do the formula here to find a missing one. Here it was more graphical. If you know distance from center to foci is C, distance from center to vertice is A, you know, length of minor axis, cut into half, that's how you get B. All that good stuff, that will help you out, okay? So go ahead and, oh, there's one correction on 22. It's kind of a weird, down here, the last problem. Kind of a weird question. It says like the sum of the distance and something something. It gives you the foci, and just use those points, and then it gives you a value of 10. Just say that the major axis is 10. Major axis is 10. Okay, so yeah, the directions are kind of weird. So, and that'll make it straightforward, and it'll feel like just like one of the problems we just did right here. Okay. All right, you got the rest of the period? Go ahead and get started.